Section 11.3 is surface areas of pyramids and cones. So I gave you some vocab up here at the top. A pyramid is a polyhedron in which one face, the base, can be any polygon. So this one is a hexagon, so it's called a hexagonal pyramid. And then all the other faces, which are the lateral faces because they're on the side, are triangles that meet at a common vertex called the vertex of the pyramid. So you can name a pyramid by the shape of its base, which is why this is called a hexagonal pyramid. The altitude of a pyramid is the perpendicular segment from the vertex to the plane of the base. So here's your altitude. The length of the altitude is also the height. So those are the same things. A regular pyramid is a pyramid whose base is a regular polygon, such as a square pyramid, and whose lateral faces are all congruent isosceles triangles. The slant height is the length of the altitude of a lateral face of the pyramid. So in other words, the slant height will be from the vertex to the side of the base. So it won't go perpendicular down to the base, it will be going along one of the lateral faces. So what we're going to do is we're going to find the surface area. And just like when we were doing prisms and cylinders, we had to use lateral area. And so for this, when you're doing the surface area of a pyramid, the lateral area is a half times P, which is perimeter of the base, times that cursive L, which is the slant height. And remember, that's on one of those side faces called the lateral faces. So we're going to do lateral area plus, and since we only have one base on this, you just have to add on the area of the base. So let's take a look down here. So here's my formula. I need to find the lateral area, so that's a half times the perimeter of the base times the slant height. So just in case you can't see, these red marks that I drew over here should be on your picture, and if they're not, please take a moment to draw those in. So this should be showing you dashed lines and then a perpendicular line from the center of the base to the outside as 3 square roots of 3, and then it should be showing you the slant height over here as 9. So what I did is start plugging in numbers. So I had a half times perimeter of the base. So each side is 6. I have 6 sides, so that's how I got 36. My slant height is 9, so I plugged in 9 there. Area of my base, this is a regular hexagon. So remember, for a regular hexagon, you have to do a half times apothem times perimeter. So my apothem is why they drew in this number here. So my apothem is 3 square roots of 3, and then the perimeter we already found was 36. So then I just multiplied this set and got 162, multiplied this set and got 93.5, and then I added those two numbers together. So this would be a problem where they gave you everything that you needed. So notice that we are applying those area formulas of the bases that we've already done in the past. Okay, you pause the video and see if you can do the next one. So on the next one, we have our surface area formula, and then we have to find the perimeter of the base. So it said my base edges are 5 of a square, so that's why I did 5 times 4 and got 20. The slant height they told me was 3, and then it wants area of the base. Well, the base is a square, so if my base edges are 5, I can just do 5 times 5 and get 25. So then I times these two and then added to 25, and I got 55 as my final answer. So this one not so bad because area of a square is not too bad to calculate, but if it's an area of one of the other ones with the regular polygons, a little bit more challenging. Okay, so let's look at one where you might have to find the slant height before you can get started. So still using the same formula, and they gave me a pyramid over here. They told me that the height is 36.4, and they did tell me that from there to there is 15. So if you can't see that, or sorry, no, they didn't tell me that, but we're going to find that here in just a second. So to find my perimeter, I would add up all the sides on my bases, so that's how I got 120. Now the slant height they did not give me, so I had to do some figuring. I know that all the way across here is 30, so if I connect to the center and go out, that'd be like a radius, which would be half of that. So that's how I know that this leg is 15. Notice we have a right triangle again, and I have 2 of the 3 sides. So I don't know angle measurements, which is why I'm using Pythagorean theorem. So I put 15 in for A, 36.4 in for B, and then I have to solve for my slant height. So I squared these two numbers and added them and got 1549.96. To find my slant height, I still need to come back and do the square root. So that's how I got 39.4 to find my slant height. Then I need to do the area of the base. So again, this is a square base, so I can just do 30 times 30, and that's how I got 900. So then I do my computations, and an exact answer would be the 3,264, but if we were using the rounded, it might be 3,262.2. Okay, you try the next one where you have to find the slant height before you can find the surface area. Oh, and by the way, notice that I crossed out the lateral area because I was using the problems from the book, and so you can just cross out that lateral area and we're just finding surface area. Okay, so I'm going to do a half times perimeter. So each side is 36, and I have 6 sides, so I did 36 times 6. I need to find my slant height in this case. So once again, I came over here, and I'm going to do Pythagorean theorem, where they actually give me this length, so I'm just going to plug in 42 for A and 18 square root of 3 for B. I'm going to square both of those, so I got 1764 and 972. When I added, I got 2736, and then I need to do the square root in order to find the slant height. So hopefully you got 52.3 for your slant height. Then this is a hexagon, so in this case I would have to do area equaling a half times apothem times perimeter. So for my apothem, they actually already gave it to me because this is from the center perpendicular to the outside, so I can use 18 square roots of 3. And then for the perimeter, I already found that too, it was 216. So computing all of that, a rounded or an exact answer, so 9,016.2 or 9,015.5. So a couple of things. One, those regular polygon figures come back in play, and then two, you have to use maybe Pythagorean theorem in order to find your slant height. Okay, so now let's look at a cone. So a cone is the same thing as a pyramid, except for now the base is a circle. You still have a vertex, you still have the height or the altitude, and then your slant height is still on the side. So this would be one continuous rectangle if you unwrapped it around, and then you still have your base that's on the bottom. So let's find the surface area then. Surface area is the same formula as it would be for a pyramid, which is why they group these two together. It's lateral area plus the base because you only have one base. But we know for lateral area, we're going to do a half times 2 pi r times the slant height, or just pi times radius times slant height. So this is a condensed version. So let's look at your first problem of your cone. I'm going to do lateral area plus the base, and so I plugged in that first formula and then realized that, oh yeah, we can condense that down with this piece here. So I do pi times my radius, which they show me is 15, times the slant height, which they also show me here is 25. Then I can add 2 at the area of the base. Remember, for area of a circle, it's base times, pi times radius squared. So I would do pi times 15 squared. And then it wants me to leave my answer in terms of pi, and we are going to do that on this section. So what you're going to do is you're going to multiply that 15 times 25 and get 375 and leave that pi alone. And then 15 squared is 225, and then leave that pi as a variable. And since they both have a pi, I can add these whole numbers, so I get 600 pi centimeters squared. Okay, you try the last one here. Alright, on the last one, I have my surface area formula, so then I start plugging in. So I do pi times the radius, which they told me is 16, times the slant height, which they told me is 28, and then I need to do area of the base, so I do pi times radius squared. So then I computed 16 times 28 is 448, 16 squared is 256, and then I add those two numbers with pi, so I get 704 pi meters squared. Okay, that takes care of surface area of pyramids and cones.